Hello guys, let's wait for 5 more minutes and see if any participants are joining. Then we will start our session. Okay guys, I will be sharing my screen and then we will start the session for today. So hello guys. Today we will be today we will today we will be learning about hyperbola. Like we will be revising the hyperbola chapter that we have already done. Let's get started with it. Today's agenda is revision of hyperbola. Okay, so first of all, starting with the basic definition of hyperbola. We all know every conic is defined as the distance of a the distance of a point moving point from a fixed point, the distance of a moving point. This is a moving point from a fixed point. This is the fixed point, and a fixed line. Okay, and how these distances are compared? PS by PM is a constant. Okay, so for a hyperbola, this distance of a moving point, the ratio of the distance to the ratio of the distance from a fixed line is always a constant. Okay, this is a constant, and this constant for hyperbola it is greater than 1. Okay, so this is the definition of hyperbola. You can see hyperbola is defined as the locus of a point moving in a plane in such a way that the ratio of its distance from a fixed point to that from a fixed line is a fixed constant greater than 1. Okay, now these these are some terms which we have to understand. First is our directrix, then latus rectum, then center. This is the focus, vertex, vertex, double ordinate. Okay, so here directrix is that fixed line, right? In the definition, in this definition, this is the directrix, that fixed line from which the distance of the moving point is calculated on this hyperbola is that fixed line is directrix. And then the center of the hyperbola, standard hyperbola, is 0 comma 0. Latus rectum, we all know what is latus rectum. Latus rectum is a line segment perpendicular to the axis and passing through the focus of hyperbola. Okay, so the equation, let's check out whatever these like how to mathematically justify these all terms here. So this is our standard hyperbola, and this is for conjugate of x square by a square minus y square by b square equals to 1. Okay, so the center for both the hyperbolas is 0 comma 0. Length of transverse axis is 2a. So this is the standard hyperbola. Here you can see that this length is 2a, right? So this is our transverse axis, and the length of the conjugate axis is 2b, right? And here you can see for the conjugate hyperbola, this thing has been interchanged. For the focus, see, there is a trick for these two hyperbola. You have to exchange x, y, and a, b. Then you get all, if you know one, like if you know the details about this particular particular hyperbola, standard hyperbola, then you can know the detail about this conjugate hyperbola just by exchanging the variables x, y and exchanging the variables a comma b. So here you can see this first interchange has happened here for the length of conjugate and transverse axis. Here you see that the focus, the coordinates of the focus is given by plus minus ae comma 0, and since this is the x coordinate, this 0 will come to the y coordinate and a will change to b. So here plus minus be 0 comma plus minus be. So see here also that interchange has happened. Here you can see that x, and then you have changed the variable x to y and a to b. So you got the directrix of the conjugate hyperbola. Here eccentricity is given by this formula under root of a square plus b square upon a square. And here you can see that this a square is changed to b square, and this b square is changed to a square, and this a square is again changed to b square. So the numerator remains the same since a square b square both are there, and the denominator changes. So this for eccentricity, just remember that the denominator changes from a to b. Now the length of the lattice rectum also, you can see the variables has changed to the length of the lattice rectum here is 2b square by a, and here it is 2a square by b. So the variables have changed, the numerator has gone to the denominator in the conjugate hyperbola. Now let's try to solve this question. The eccentricity of the hyperbola whose length of the latus rectum is equal to 8. Okay. So the length of the latus rectum is equal to 8. That means let's take the standard hyperbola. 2b square by a is given equals to 8, right? So b square equals to 4a. B square equals to 4a is the relation we obtain from this information. Then the length of its conjugate axis is equal to half of the distance between its foci, right? So what is the length of the conjugate axis? Length of the conjugate axis for this hyperbola, here you can see, if you don't remember, length of the conjugate axis is 2b for standard hyperbola. So here we have done 2b is given as the half of the distance between, its foci, half of the distance between its foci. For the distance between the foci, see the coordinate of the foci is plus minus ae comma 0. So the distance will be 2ae, right? So here 2b equals to ae. You get this relation here. So if you square, you get 4b square equals to a square e square, right? Now, if I simply put here the value of e square is, here you write 4b square equals to a square into e square is a square plus b square upon a square, right? So this a square gets cancelled. Here you get 3b square equals to a square. So this is also one relation and this is also one relation. Let's put it here. So if b square is 4a, right? I'll use this relation. I'll use the relation of 1 in 2. So 3b square will become 3 times of 4a equals to a square, right? So 12a equals to a square. So a value comes out to be 0 or 12 from this information, but 0 cannot be the value of a. So therefore we take a is 12. A is 12. So we got a value as 12. Now, we want to find the b value. Since a is 12, b value is b square is 12 into 4, which is 4 into 3. So b value comes out to be 4 root 3, right? So now we are supposed to find eccentricity. Eccentricity will be under root of a square plus b square, which is 144, plus b square is 48 upon a square, which is 144 again. Right. So this will come out to be 192 upon 144 under root. So this will be root of 192 can be written as 16 into 12 upon 144 under root. This is 16 1 ja, 16 9 ja. So root 12 upon 9. So root 12, we all know what is the value of root 12. It is 2 root 3 upon this can again be reduced. This will become 4, sorry, 3 4 the 3 3 the, right? So this will be 2 upon root 3, 2 upon root 3. So the answer is 2 upon root 3. Now conjugate hyperbola. We already discussed, since this is our standard hyperbola is x square by a square minus y square by b square equals to 1. In conjugate, this minus and this plus is interchanged. So this becomes y square by b square minus x square by a square equals to 1. This can also be written as x square by a square minus y square by b square equals to minus 1. So these are the two forms which we can write this in. So now the eccentricity also changes, right? So eccentricity will be under root of uh, a square. Eccentricity will be under root of a square plus b square upon a square. So this is the eccentricity formula. Now since the vertices in the standard hyperbola is a comma 0 plus minus a comma 0, vertices in the conjugate hyperbola will be 0 comma plus minus b, interchanging the variable xy as well as ab. Length of the lattice rectum in the standard hyperbola is 2b square by a. Here it is 2a square by b. Now, parametric representation. Right? Parametric representation, we have to in parametric representation, we use a third variable like theta over here to represent the coordinates, like every coordinate on that particular hyperbola. So the parametric representation for a hyperbola is x is given by a sec theta and y coordinate is given by b tan theta. And why it is done so is because you can see over here, if you substitute x and y, this x and y over here, you will get that this equation is always satisfied. A square sec square theta upon a square minus b square tan square theta upon b square. So now this will become what? This will be a square gets cancelled, b square gets cancelled, sec square theta minus tan square theta. So we all know that 1 plus tan square theta is sec square theta. 1 plus tan square theta, we know that trigonometric ratios 1 plus tan square theta is sec square theta. So sec square theta minus tan square theta is 1. So you can see that this equation has been satisfied, right? So that is why the coordinate is like this. Now this q theta is given as the equation, like the coordinate of parametric coordinate of the points on the auxiliary circle, right? Now equation of a chord of the hyperbola joining the 2 points. So these 2 points are parametric points, and the equation joining the chord, equation of the chord joining these 2 points is given by this formula. So I want you guys to remember this formula. So this is the equation of chord in parametric form. Okay. So what is the equation? X by a cos of, if you want to remember this, you can remember like this. This alpha minus beta, alpha plus beta, alpha plus beta. So this you can remember by this thing. Just remember this and then cos sine cos. Cos and sine are in alternate. Now, position of a point with respect to hyperbola. So we all know how the position of a point with respect to ellipse was defined. Similarly, the position of the point with respect to hyperbola will also be defined if x1 square by a square minus y1 square by b square minus 1 is 0, then it is on the hyperbola. If it is greater than 0, then it is outside the hyperbola, and if it is less than 0, then it is inside the hyperbola. So these are the points that we have to remember. Now find the position of the point relative to the hyperbola, right? So the equation of the hyperbola is 9x square minus y square minus 1 equals to 0. If we substitute this point, let's see what we are getting. 9 into 5 square minus 4 square minus 1. So this comes out to be 25 nines are 225 minus 16 minus 1. So this is greater than 0. This value is greater than 0. Hence the position of the point is outside the hyperbola. Now line and hyperbola topic. The straight line y equals to mx plus c is a secant, a tangent, or passes outside the hyperbola according to this condition. Okay, if c square is greater than a square m square minus b square, then it is a secant. If c square is equals to a square m square minus b square, then it is a tangent. And if c square is less than a square m square minus b square, then it passes outside the hyperbola. So please remember these three conditions. Now condition of tangency. So c square is a square m square minus b square. You can remember it like this. Or if you want to remember it, you can also remember it like this. So BCA, right? You can remember it like this, BCMA. Okay. So B square plus C square equals to M square A square, BCMA. Now let's solve an example. If 2x minus y plus 1 is a tangent to the hyperbola, then which of the following cannot be the sides of the right angle triangle? Okay, so let's try to solve this question. First of all, this is a tangent to the hyperbola. A square is a square, b square is 16, and the line is given to us as 2x minus 1 equals to minus 1. So the y equals to 2x plus 1, right? So the slope of this line is m is 2. So what and c value is, and m is 2 and c value is 1, right? So c square should be equals to a square m square minus b square, right? What we will do here, we substitute these values. 1 square equals to a square is a square, and m square will be 4 minus b square is 16, right? So this will become a square comes out to be 17 upon 4. So a value is root of 17 upon 4. Now, which of these following cannot be the side of a right angle triangle? So this is our question. Root of 17 upon 2 cannot be the side of the right angle triangle, right? So first let's check for this a 4 comma 1. So a is root 17 by 2. This is 4, this is 1, right? So a, if you subtract these two, root of 17 minus 17 by 4 minus 4. So this cannot be like, if you use the property like Pythagoras theorem, then you find that this cannot be the side of right angle triangle for A42. If you find out A42 is the Pythagoras theorem, this again won't be the side of right angle triangle. 2a comma 8 comma 1, 2a is root 17, root 17 comma 8 comma 1 won't be the side of right angle triangle, and this will be the side of right angle triangle. See, 2a is how much? 2a is root 17. Now 4 square plus 1 square is equals to root 17 square, right? So that is why this thing is the side of right angle triangle. So there are three answers for this: A, B, comma C. See here. Now, equation of the tangent to the hyperbola in three types of equations. First is point form, parametric form, and slope form. So point form is given by this equation. What we have done here is we have just substituted. See, if I write x x square by a square minus y square by b square equals to 1, right? So what we can do to wherever in conics you want to find the equation for ellipse and hyperbola, this is the trick for ellipse and hyperbola only. So please don't use it anywhere else. You write this equation as x in upon a square minus y upon b square equals to 1, and substitute any x or any y x1 comma y1, right? So this equation will be obtained. Now slope form, right? The slope form is we know the condition of tangency. C is equals to a square m square, c square is equals to a square m square minus b square. So this is our c value. We have just substituted that c value in the line equation y equals to mx plus c, right? So if this c is satisfying this condition, then we know that it is a tangent. So these are the contact points of these tangents. Okay, so these are the contact points of these tangents. So you have to remember this. For remembering this thing, you can remember it like this also. For an easy method, if you want to remember, you can remember it like this: plus minus a square m upon c, comma minus plus b square upon c. So you can substitute the denominator as c, right? Okay. Now equation of the tangent at this point, right? So to prove this thing, you can simply substitute this point in the point form of equation. So if you put that value x into x1 is our a sec theta in this condition, minus y into b tan theta upon b square equals to 1. Here you can see 1a gets cancelled, 1b gets cancelled. Then what is remaining is x sec theta upon a minus y tan theta upon b equals to 1, right? Let's move ahead. Example. So here you see one more point was given. Note that there are two parallel tangents having the same slope m, right? There are two parallel tangents, and why these two parallel tangents are coming? Because of this plus minus sign over here. So y equals to mx plus c and y equals to mx minus c is the are the two tangents. You can see that both these tangents are having a slope of m. So the equation of tangent to the hyperbola parallel to this line will be what? So this what will it be? So for one equation is x minus y equals to 2, and the parallel, since it is parallel, this will be x minus y equals to constant, will just change the sign. So it will be this equation. So this was a very easy and conceptual question asked in JEE Mains 2019. Oh, sorry. This is not a tangent. This is a line which has been given, and this is a parallel line. So okay. So what we will do here is x y equals to x minus 2 is given. So we know that the value of m is the value of m is here. What is here? M is 1, right? So we know the value of 1. If you so value of m, if we want to find out c, so c will be equals to plus minus under root of a square. Here we will convert this equation in the standard form. This will be x square upon 5 minus y square upon 4 equals to 1. Now we will substitute the value of a square. This is a square and this is b square. So a square is 5 and m square is 1 minus b square is 4. So we get c value as plus minus 1, right? So therefore the equation of the equation of the tangents which are parallel to this line is x minus y equals to plus minus 1, right? So please do not forget that there are always two tangents possible for two tangents for one slope. Okay, the solve the eccentricity of the standard hyperbola passing through the point 4 comma 6 is 2. Then the equation of tangent to the hyperbola at 4 comma 6 is what? So what has been given to us is, let's consider the standard hyperbola as x square by a square minus y square by b square equals to 1. Okay, so first of all, we will obtain a relationship by substituting this point, and it has been given to us that this hyperbola passes through 4 comma 6. So we will substitute, we will get 16 upon a square minus 36 upon b square equals to 1. So this is one equation we are getting, and now the another relation between a b that we will find is because of this eccentricity. Eccentricity is given to us as 2. So eccentricity square will be a square plus b square upon a square. So this will become 4a square equals to a square plus b square. Now b square will be 3a square. So we will simply substitute this thing in this equation. We will get 16 upon a square minus 36 upon 3a square equals to 1. This will become 12. Now this will be 4 square. So a square, a will be 2, right? Since a is 2, b square will be 3 into 4, which will be 12. B will be 2 root 3. Okay, so we got the values of a and b. Now the equation of tangent passing through this point on the hyperbola, we have just seen that it is x1 by a square minus y1 by b square equals to 1. So x into x1 is 4 upon a square is 4 minus y into y1 is given 6, b square is 12. This will be 1. So 4 gets cancelled, 6 ones are 6 twos are. This will become 2x minus y equals to 2. So this is the equation of the tangent on this point. 2x minus y is 2. So you can see here. Now equation of pair of tangents. So this is something that I would suggest you to remember, because this has been used throughout the conics, right? So the equation of pair of tangent on any point to the hyperbola, from any point to the hyperbola, is given by s1 equals to t square. We have to just remember s is the equation of the hyperbola, s1 is when you substitute x1 comma y1, and t is the equation of tangent, this. Okay, so you can remember it like this: s is hyperbola, s1 is hyperbola h1, s is hyperbola when you substitute the point, and t is tangent. Equation of the chord of contact is given by what is the equation of the chord of contact of the tangents? Equation of the chord of contact of the tangents is given by equals to 0, and t is the equation of tangent at that t is the equation of tangent if that point was on the hyperbola. Now equation of chord of the hyperbola whose middle point is given. Now in this diagram you can see this is the chord to the hyperbola and that middle point is given to us. Then the equation is t equals to s1. So this s1 t, all these things will never change. These are the same things in all the okay. Now the locus of the intersection of tangents which are at right angle is called as director circle. So director circle has a basic definition in throughout the conics as well. Same definition throughout the conics. So I think the important point in conics, the trick to conics is to remember one chapter thoroughly. And then even if you forget, you can choose this one chapter to be circle. Even if you forget anything in the other chapters, parabola, hyperbola, or ellipse, all the method are same for entire conics. Method is same. You can derive the formulas in the exam to fetch you marks. Okay, so equation of the director circle, if you guys remember, in the ellipse, it was x square plus y square equals to a square plus b square. Here, simply that plus sign in the constant term has been replaced by the minus sign. So it is very easy to remember this also. Now, the locus of the middle points of a system of parallel chords with slope m. So what does this mean is, if you draw a chord, see there it is drawn. I am just trying to draw here. If this is a chord, this is a chord, this is a chord, this is a chord. Okay. If you draw these parallel chords, all these are parallel chords, and it has a slope m, right? So the center, the locus of the middle points, like if you go to the middle point, so this is the diameter. This is called the diameter of hyperbola. And the diameter equation is given by y equals to b square x upon a square m, right? So hyperbola has a lot of diameters, so that is why every time you change the slope of the chords, you will get a different diameter, right? So you can say that hyperbola has infinite diameters. Tangent at infinity, so asymptote definition is to draw tangent at infinity. We are drawing these tangents such that they just seem like they are grazing through the hyperbola, across the hyperbola, and we assume that since they are closing in on the distance of like with the hyperbola, so eventually we cannot tell how far they will meet with the hyperbola, so we consider it to be at infinity. Okay, so these both tangents are meeting the hyperbola at infinity. So we assume that there can be a tangent at infinity, since infinity is a concept which we are not very sure about, so we just assume that they are meeting at infinity. Hyperbola and its conjugate have the same asymptote. So this is an important point to remember. So whether you draw hyperbola like this or you draw hyperbola like this, since this and this are conjugate to each other, their asymptotes will also be same asymptotes. The asymptotes pass through the center. This is important point which helps to solve questions easily. Now, axis of hyperbola bisects the angle between the asymptotes. What is this saying? If the angle between the asymptote is beta, then this angle will be beta by 2. This angle, if this angle is alpha, so this angle will be alpha by 2. Equation of the hyperbola and its asymptotes differ by a constant only. This is also a very important point, why it will help you solve questions when you have to when you have to find when you have to find the equation of asymptote. The angle between the asymptotes is given by 2 times of tan inverse b by a. This is supposed to be remembered. Now the equation of the asymptotes of this hyperbola. So we know the hyperbola. We have to find the equation of the asymptotes of the hyperbola, right? So we know that the equation of the asymptote will differ only by this constant, only by this constant. So how will you find the constant now, right? First of all, you will find the center of the hyperbola and you will define. So if you try to reduce this hyperbola, what will it become? Let's check. See, first of all, the equation of the this is the only difference, right? The constant is only differing, everything is same. Now it should represent a pair of straight lines. So the straight condition for the pair of straight lines, if you guys remember, was ABC plus 2FGH. This was also written in determinant form. So you need to remember the variables in determinant form. So ultimately this changes out to be this. I prefer to remember it like this since it has a cyclic pattern into it. ABC, FGH, AF, BG, CH. So we put the values, we get the value of lambda. Lambda comes out to be minus 3. So therefore the equation of the asymptotes will be this. Find the asymptotes of the hyperbola xy minus 3y minus 2x equals to 0. So this is also the similar thing. In this what we can do here is if I try to this if I try to this is x minus 2 into sorry this is x minus 3 into y minus 2 equals to 6, right? So this is that equation. Now we know the center is 3 comma 2. So the equation of the asymptote will be xy minus 3y minus 2x plus lambda equals to 0, and 3 comma 2 will satisfy this equation because asymptotes pass through the center. So we will substitute, we will get 3 into 2 minus 3 into 2 minus 2 into 3 plus lambda is 0. So we get lambda value as 6. This gets cancelled, we get 6. So the equation of the asymptotes to the hyperbola is xy minus 3y minus 2x plus 6 equals to 0. Now rectangular or equilateral hyperbola. So rectangular or equilateral hyperbola, how let's see what it is, how it is defined. First of all, the hyperbola is called rectangular if its asymptotes are at right angle. So the basic condition for a hyperbola to be called as rectangular or equilateral hyperbola is that whenever you draw the asymptotes, so consider this was the hyperbola, and if you are drawing the asymptotes and this angle between them is 90 degree, then it is a rectangular hyperbola. The asymptotes to the hyperbola, the asymptotes of this hyperbola are y equals to plus minus b by a into x. If they are perpendicular, so this perpendicular, the product of the slope should be minus 1. So we get minus b square by a square equals to minus 1. So b square equals to a square. So the equation of rectangular hyperbola can be written as x square minus y square equals to a square, since a square and b square are equal. Some important points about the rectangular hyperbola. So we know that a square is equals to b square. So you can find the eccentricity. E square is given by a square plus b square by a square. So this will come out to be 2a square by a square. This will be 2. So eccentricity of a rectangular hyperbola is always root 2. Asymptotes are y equals to plus minus x. Rotating the axis by angle minus pi by 4. Whenever you rotate the axis in this direction for minus pi by 4 in the in the clockwise direction, sorry, in the clockwise direction about the same origin. Okay, so we have to remember that we have to keep the origin as same and we have to rotate this axis like this. So the new axis are like this and like this. then the equation of the rectangular hyperbola is reduced to xy equals to a square by 2. Xy equals to a square by 2. So this is also written as xy equals to constant. So this constant is represented by c square, k is equals to c square. You have seen these type of equation in chemistry, physics somewhere. PV is constant, right? Where sum of pressure into the product of pressure into volume is constant when the temperature is constant, right? So under isothermal conditions, PV is constant. So this is the graph of PV under isothermal condition will always be a hyperbola, and it will be rectangular hyperbola. Now in xy equals to c square, asymptotes are the coordinate axis. Rectangular hyperbola is also called as equilateral hyperbola. These are some points regarding rectangular hyperbola. So the parametric representation is ct comma c by t. Now if you use this parametric representation in all the equations that we have studied till now, you can find the equation of chord, equation of tangent, equation of chord given in the middle point when the middle point is given, equation of normal, a vertex of the hyperbola, focus of the hyperbola, and the directrix of the hyperbola plus the latus rectum, right? So latus rectum, so this is the point to remember. The latus rectum is equals to transverse axis and conjugate axis for rectangular hyperbola. So nothing changes about rectangular hyperbola. Nothing changes about rectangular hyperbola. You just have to remember that xy equals to c square, where c square is a square by 2. This is also a hyperbola, right? Okay. I hope the session was understood by you guys. Have a good day.